the data deluge. A topic, I think, which is very much close to many of our hearts. I've known Seamus for many years. He is a distinguished digital humanities scholar and also an expert in terms of digital curation and preservation, and indeed was previously an assistant director of the Digital Curation Centre, and he is now based at the University of Toronto. Seamus.
Hi, it's great to be here. Wonderful to see so many people. I have to be honest, it was a relief when I got off the plane in San Francisco and found that I was in a warm place for a bit. We are the source of the polar vortex. And I'm sure that that's room for lots of data crunching as well. So I'm going to try to answer a question that somebody asked me when I was asked if I would come talk. How are we transforming education and training of researchers? And in doing that, I was just to grow on my digital curation, preservation, curriculum development work. Well, guess what? The answer to this question is very simple. We're not. Okay? It's a little disappointing to start off by saying that, but it is the case that we are definitely not doing it. So I'm going to talk a little bit about what the issues are and why we're not doing it, and where we're going to go, where we should be going in terms of addressing some of the questions. I'm also going to point out that there were a couple of different ways that I could slice this cake. One is that I can talk about education at the doctoral level, how we're giving students an opportunity to invent new ways of doing things. I'm not going to talk about that, because the bulk of what I'm interested in at the moment is my professional education program, and how not just my school, but the I schools and library and information studies programs across the world are trying to produce graduates who are actually able to contribute in the data society. So in talking about this, I reflected on the work of the DCC, the DigiCurve family of projects that was at SILS, UNC, a project that Carol Palmer has at Illinois. I'm going to very briefly talk about DigiCurve EU-funded project, but in pointing to here Laura Malloy, not because this is a solution, but because it offers us a paradigm that we could use to talk about developing curriculum programs for research data. And I crawled the websites, or actually one of my colleagues, Andrew Drummond, crawled the websites of the I schools and the LIS schools when we introduced a table, which we abstracted some of what actually schools claim they're doing in the areas of digital preservation and curation and research data. So I noticed, I believe that the definition of what digital curation is has changed since I was at the Digital Curation Center. It seems now that digital research data has come to be a core term in the definition of it. And that's how I came to realize that we could use digital curation to be an umbrella term for this big data and data research. Actually, I would really rather, instead of just saying research data, we used a phrase like digital material. Because we just don't, and I think this is true of all of the I schools, we just don't educate students who are going to go out and work in academic libraries or support research data institutions, or work with research data scientists. We also educate students who we hope are going to go out and work in industry and contribute to the bigger data analytics framework. So I'd like to get a slightly broader term than pure research data. And data for me isn't sufficient, because the other challenge that we face is that memory institutions have really been the key shaper of discussions about digital curation. So when we talk about it, we're constantly talking about it from an archival, records management point of view, or or an LIS point of view. We're not actually looking at it from an industrial perspective, from the perspective of organizations that are trying to mine data in order to improve their productivity, to improve their socioeconomic well-being, to decide and shape public policy. The other thing is that when we talk about digital curation, we've also been focused on curating data and not on creating value from it. It's one of the things I really found welcoming about the shape of this conference this year is that now we move up the agenda to the point where we're able to talk about creating value from it. So, and I particularly liked this this particular definition of the issue from Kostas Dallas and Panos Konstantopoulos. Captures very well what the traditional approach has been, right? Adding value to a trusted body of digital information for current and future use, and adding different kinds of description and linkages to it, and ontologies to make it more usable. And this is in a lot of the ways that Jim Hunter was talking about before, in terms of the ability to extend and to create resources that are fit for purpose. But we need to move beyond the scientific and scholarly significance. And the reason we need to do that is we need our students to be able to fill the broader marketplace. I'm sure we've had the McKinsey report come up already. You're all familiar with it. It's a wonderful 2011 report. It's fantastic because it's filled with lots of powerful examples as to obviously the power of data in transforming retail, healthcare, transportation, and they went on to look at other things in other areas like education. And if I go back and just think about my own country, Canada at the moment, we're looking at needing 14 to 19,000 people who are educated to be data scientists by 2018. We're not producing them out of the LIS and I schools. There's a need for 150,000 managers. And I think if you take this to Europe as a whole, that you have the same figures, the population is roughly about the same, that you have for the US. So this is a big market sector for education. We're not tapping into it. For me, though, the most transformative book about big data was Ian Ayres' Super Crunchers back in 2007. Unfortunately, it also pointed out my own inability to manage data because I had a wonderful image of myself lying on the beach actually reading this book, and I couldn't find that image anywhere. Although I know I've used it in several presentations. But the key thing about this is that he was able to demonstrate really with evocative examples, the transformative power of big data on companies, on predicting your behavior. And it left me with one question. What were the key essential ingredients that we needed to have to educate people in this arena? And we'll talk a little bit about that. But as you've already seen, this market is absolutely huge and growing. This is Wikibon is a wonderful source for all kinds of up-to-date information about what commercial developments are in the big data arena. You want to know what the latest developments with the Hadoop are, or with the new tools from MapReduce. They've got a ton of information there for you to help you come to grips with it. So, in Canada, the Olympics was big for us. And I'm afraid that, so I caught hold of the Canadian Sochi fever. And I like this Jamaican team because they were filled with aspirations. They really went out there and they tried their best and they pushed the goal out. And that made me think very much of what it is that we're trying to do. But we're limited by the technology that's available to us, the curricula we've developed, the resources that we have to develop educational programs, and we're also limited by the student base that we're able to tap into. Predominantly, our students some don't come from an STM background. That is a big issue. So they don't come with knowledge of statistics. Some of them come with psychology, but most of them, which is a useful thing, they don't come with data management knowledge. And so we're having to develop all those things, helping develop all those things. And so the hottest thing on ice reminded me of an article on what a data scientist is. And I think that it's important to recognize that doing data science is a process of modeling, discovering, operationalizing, and cultivating. And it's a conversation that makes data science work. So we need to find a place where we can educate our students to fit them into that conversation so that they can play a role. That means we do have to, in some ways, change the way we educate. I think Liz Lyon really, I brought a slide from her, she captured the layering of roles and places that a data scientist can play, from being an engineer to being a data journalist, and the different ranges of activities. So the data librarians, for instance, play a very important role in collection development. If you want to, one of the great things about Ian Ayer's superconscious was that he didn't just tell you about how you use one data set to reach some conclusions and make some predictions, but he actually showed how you made data sets interoperable to do just that. And that's something that data librarians really will play a role in, data analysts as well. Getting the right kind of data sets there. So, what's our data scientist going to be? It's going to be an engineer, someone who can apply the scientific method and data discovery tools to make new insights. And it's interesting that I like this fact that it was, Gil Press described the best data scientists as a product and process innovators. That in order to be a good data scientist, you always have to be creative. You have to be pushing the boundaries both of your tools and the kinds of questions that you're going to ask. So, we want our data scientists to have domain knowledge. And that is a very, very long-standing point of view. That goes all the way back to, from my first reading of that, goes back to a review that was done at NASA data centers in the 1990s when they argued that it was relatively easy to teach people how to do appraisal, to manage data, but if they didn't come with a knowledge of astrophysics and a knowledge of other relevant scientific disciplines, they just couldn't work with data. They just didn't understand it well enough to ask meaningful questions and they handle it. So the domain knowledge is important. Rich technical know-how, ability to apply it creatively, collaborative spirit, intellectual curiosity, so you really want to ask new questions. And you have to be a great storyteller. And when I looked across the gambit of literature that's about what a data scientist looks like, from that Harvard Business Review through to a range of other articles in both popular and scholarly journals, these were all characteristics that we have. So how do we educate these kind of individuals? And more importantly, how do we actually think we're going to measure whether or not they retain these abilities? Because the marketplace has to have confidence that we are actually able to turn out and deliver students that are capable of doing data science. So what it is it's experimental. It's all about experimentation. And this guy, I think he was talking about the problem that he faces with having just Virgin Atlantic having bought a few 787s. And on every flight, they're generating half a terabyte of data. Wow. And what he wants to do is use that data to predict failures, hopefully so they get those lithium batteries before they actually do fail, and to decide what kind of maintenance needs to be done and so forth. Now, those you can take those, as you've seen, across hundreds of other examples, but it's experimentation that's really the key here. And in terms of trying to understand what other people were thinking about this, I looked at a number of different things as sources, as I said. And I found, for example, Cal Lee did some marvelous work on digital curation, knowledge, and competencies. It's really a resource on what it is, the know-how you need to have if you want to be a digital curator. But it doesn't really capture the aspects of adding value, of creating value from the resources that you have. It's about managing them and securing them, and we need to move beyond that. The landscape in the iSchools doesn't look that good. Now, it would have been better, I confess, and something that if I carry on to do anything else with this, I will do. It would be nice to have a survey of these iSchools to actually, instead of basing it solely on their websites and publicly available material. But there are programs like Berkeley and Michigan and Maryland and Washington seem to be doing a good job at providing resources and approaches that will turn out data scientists. There are a lot more schools than that, and there's a lot more demand for folks educated. So what was it that a data scientist really needs to know? Well, you need to know about a whole lot of fundamental things about data. You need to know a lot about text mining. You need to know about databases. You need to know about machine learning. And then you need to be able to combine all those things into asking really good questions. So, curation from a preservation sense, data analytics, visualization. They definitely have to know statistics, and not just introductory stats, but a lot of predictive statistics. If you really want to work with the large data sets, you have to be able to do work in machine learning. And that turns to automation and to the important role in terms of that automation plays, in my view, in terms of preservation. Metadata provides data quality, interoperability, and collection. And it gives me pause to just talk about one aspect of it. In the Blue Ribbon report, they picked up a report from the IDC survey, a white paper on data, and they showed that this is an old one from 2012, that there was a gap between the available information and the available storage. And I saw this really graphically presented by a cancer researcher who's doing genomic research and accumulating vast amounts of genomic data about individual tumors. And this, we need people who know how to do appraisal, selection, and collection development, because it's not just about what you can get out of this stuff, but it's about making sure we're keeping and securing the right stuff to support research into the future. So I think we need a new kind of educational experience for our students. One that's empirical, one that's experimental, one that's exploratory, one that has action. And I use action instead of practice, because action for me, is a sense where you use method and theory and you engage students in doing things. They work on case studies, they work on real data, and we have public and private placements for them in apprenticeships, so that they can actually have the fun and pleasure of playing with the data to stimulate their intellectual curiosity and do new things. So, I was going to talk very briefly about Simmons College, for example, has developed a data curriculum laboratory for students that I thought was pretty attractive, and it has it's a good paradigm, I think. And there's a Jeanette Bastian who feels a couple of very good articles on it. So our next steps, we really need a digital curation and data science canon. What are the core texts that a student needs to have read before they graduate? We need a plug-and-play curriculum model so that there's some consistency in the way we're educating our students across different places. We need to create data science and data curation laboratories where experimentation is actually possible. And we need a whole bunch of resource data banks to give students the plug-and-play data that they can experiment with. My favorite example in this is, if you're only going to keep an 8% sample of some data, what is that 8% sample? You can actually play with data to decide what that is, and it's a wonderful opportunity for students. Students also need to understand the notion of collaborative laboratory work. By providing the laboratory environment to do that, we'll make that possible. They need industrial collaborations where they can, because getting access to really good raw data is very hard, and getting good placements provide that. We also want our students to question, to say, you know, I don't believe that. Why did they say that was the case? And the wonderful thing about Ian Ayres' studies is that they really do show the power of the question and using the data to ask questions. So we need to deliver a diversity of learning opportunities for our students. We have to make sure they have a range of abilities, not just deeply technical, but lots of social and ethical knowledge and capacity. We also have to engage and recognize that learning has to be continuous. It is not something that they're going to come out of our courses and say, oh, I got it, I don't need to learn anything. They have to keep going back to the educational thought. And finally, whatever we do with these programs, I really believe that we need to have an independent accreditation of the program that's much more robust and much more focused on data science than it is on current approaches. Also, I think we need to encourage them to be information entrepreneurs. And if you look, this is another McKinsey report that came out in October on open data, which is actually extremely good. And it reminded me of a presentation that Peter Weiss gave many years ago. It was from the Meteorological Office in the US. He gave an AirPanet workshop in Lisbon that Joy Davidson helped organize. And he talked about the power of public data for commercialization of enterprises. And I think we need to open our minds of our students to do that sort of thing. And there are lots and lots of opportunities. And increasingly more will be more of them as more and more governments release material. So as I say, accreditation is important. We need to do something there. But so for me, the future of digital curation education is delivering meaningful, exploratory, empirical experimentation opportunities for our students, attracting a broader range of students in STM. And there's a great little video of Christine Gordon talking at the Oxford Internet Institute last May, which I think students from STM, if they actually look at that, they can see the possibilities of actually pursuing this in a way that other kinds of communication just don't do it. We need to increase the technical capacity of our graduates, and most importantly, we need to control the landscape to drive the agenda. We're way, way behind on the curve on this, and there are other disciplines that are going to steal our march if we don't actually get our act together and get them. Thank you.
Very much, Seamus. Again, we have a few.
We need everybody else.
Okay, we have a few more minutes for questions and comments. Can you wait for the microphone, Mark?
Thanks, James. It was a great talk. Mark Parsons, Research Data Alliance. A couple things I took from your talk is, especially with your definition, various definitions of data scientists, is that data scientists are generalists. Maybe focused generalists. But and also I look historically at where data scientists come from. And they come from the domains themselves. They come from computer science, web science. They might come from sociology or geography. One of the best data scientists I know was trained in philosophy. This to me seems it's not just an high school problem. And so I'm just wondering if you, and your last comment was we don't want to let the other people steal our march. But don't we actually want to engage with those other professions, those other disciplines, those other departments? Just wondering if you have any comments on that.
That's a very fair point. Yeah, we do want to engage with other disciplines, but one of the big issues here, and there's a wonderful report on, I think it's called The Problem of Data from Clear. Recently, a great little OCLC report that came out in December about libraries, is that libraries would like to have a place in the data landscape, in the managing of research data and so forth. And currently, the average student that comes out doesn't have the capacity to actually make a significant contribution in managing data and doing that, have the technical depth is required to handle it. So I think we need to up our game. We do need to collaborate better with other institutions, but the iSchools as a group have a very powerful notion about what information is and its place in society and the way that it shapes the future of society. And if we're going to maintain any kind of hold of that particular agenda and that belief, we have to be able to educate students who have the capacity to be able to follow through technically with the agenda that we're laying out. But I'm not saying that there are other disciplines don't contribute to making this, because that's one of the roles of collaborative teams. But it's a problem about finding our place and finding the place, the key points of collaboration, where we can develop things and where we can borrow them from others.
Enough time for one more very small comment or question? Short one. Okay, thank you very much.